Classifying acids and bases isn't just about memorizing definitions, it's about understanding their behavior in reactions. Different classification systems highlight different properties, whether it's their chemical origin, the number of ions they release, their strength, or their acidity or basicity. With proper classification, chemists can select exactly the right acid or base for a given process, whether in the lab or industry. Acids are substances that produce hydrogen ions when dissolved in water. According to Arrhenius, an acid increases the concentration of hydrogen ions in aqueous solution. Bronsted and Lowry define acids as proton donors. They hand over hydrogen ions to other molecules. For example, hydrochloric acid in water dissociates into hydrogen ions and chloride ions, ready to react. Sulfuric acid and nitric acid are other common acids you will encounter both in the lab and in industry. Basicity tells us how many hydrogen ions one molecule of an acid can produce in solution. Monobasic acids like hydrochloric acid produce only one hydrogen ion per molecule. Dibasic acids like sulfuric acid can produce two, while tribasic acids like phosphoric acid can produce three. This property directly influences how much base is needed to completely neutralize the acid in a reaction. Strength refers to how completely an acid ionizes in water. Strong acids like hydrochloric, sulfuric, and nitric acid dissociate almost fully, giving a high concentration of hydrogen ions and a low pH. Weak acids like acetic acid and carbonic acid ionize only partially, resulting in fewer hydrogen ions and a higher pH compared to strong acids of the same concentration. Bases follow the same logic. Strong bases like sodium hydroxide and potassium hydroxide fully dissociate in water, producing a high concentration of hydroxide ions. Weak bases such as ammonium hydroxide or calcium hydroxide dissociate only partially, making them less caustic and more suitable for certain applications where a gentle action is needed. The acidity of a base tells us how many hydroxide ions each molecule can release. Monoacidic bases like sodium hydroxide release one hydroxide ion. Diacidic bases like calcium hydroxide release two, while triacidic bases like aluminium hydroxide can release three. This is a crucial factor when calculating how much acid is needed to neutralize a given amount of base. Strong acids and bases are workhorses in industrial chemistry, from making fertilizers to processing metals. Weak acids and bases are important in food, pharmaceuticals, and delicate laboratory work. Organic acids dominate natural processes, while inorganic acids dominate manufacturing. Understanding these categories ensures that we select the right reagent for the right job while keeping both efficiency and safety in mind. Let's quickly summarize what we've learned about classifying acids and bases. First, remember that we can classify them in multiple ways by their origin, their strength, and their acidity or basicity. Second, organic acids are usually weak and less corrosive, whereas inorganic acids tend to be strong and much more corrosive. Third, the basicity of an acid and the acidity of a base depend on how many replaceable hydrogen ions or hydroxide ions each molecule can provide. Fourth, strength, whether an acid or base is strong or weak, affects how well it ionizes, its pH value, its electrical conductivity, and how reactive it is. Finally, this classification is not just theory, it helps chemists choose the right acid or base for industrial processes, laboratory experiments, and accurate stoichiometric calculations.